Dah. Okay, Assalamualaikum warahmatullahi wabarakatuh. So, this is Group C for the project robotic hardware. So, my name is Mishraq Jamal Fazil. So, with me is Ikwan bin Amir Hamzah and also Muhammad Salim Banawir. So, our project will be doing a project for the name of the robot is the Moby Duck robot. Okay. So basically, this robot is a water and land robot. So this is an amphibious robot. So and also known as the amphibots. So the amphibious robot is appealing due to their wide range of application in resource and exploration, and also disaster relief and decolonization. Okay, so however, in developing the robot that can assembly on both water and land are extremely difficult because they must be equipped with the numerous versatile mechanism. Okay, so in this project, a duck webbed feet spire robot, which called Moby Duck robot, was designed in this paper. So basically, has the feet and also floating design, like a mechanism of a duck. Okay, so next is for the design problem. Okay, so the exploration into the unknown areas, different terrain and terrestrial obstruction and water has become prominent nowadays. So other than that, and also the delivery services, especially in time of crisis, have become more dangerous, whichever is also a concern lah for people. And also next, which is for the problem statement. So in this project, the explorative mission and the delivery service on the search and rescue mission in the areas involving land and water, such as tide, cave, crossing deep ocean, lakes with unknown and rough terrains make human presence risky and impossible. Okay, for the objective of this project, we are aims to design and develop model of robot that mimics the webbed feet of a duck. And next is to design a partly waterproof robot that can swim, float in the water and also walk on land. And also to allow both land and water explorative mission delivery service on search and rescue mission, especially in the remote and dangerous area. Okay, this is the basic system architecture for our project. So we will be using the Arduino Mega as our main controller. So backup by the Lion battery. Okay, so and also the actuators, which is we will have the waterproof servo motor, the motor driver, and also DC gear motor. So the DC gear motor and also servo will be needing in 4 units lah. And next is the navigation system, which will be using the water sensor, the LiDAR, and also the GPS module. And next is the data collection will be mostly mainly on the camera module. So and also the data communication will be using the radio frequency module and also Wi-Fi module. So basically, this will be explained later in this webinar. Okay, so next is the bill of material for our project. So this is the total price is around 1,700 ringgit Malaysia. Okay. So next is the overall mechanical design for our project is, okay, the first one you can see that the design of the robot feet is inspired by the duck webbed feet design, as you can see in the figure shown. And the design of the webbed feet also allows duck to travel both land and water. So therefore, by applying the webbed feet design, our robot will be able to travel in both environment as well. On land, the robot main maneuvering mechanism will be 4 leg attached to the DC motor, while the feet will be in stationary. So whereas in water, the robot feet will be submerged in the water, similar how ducks submerge half of its body in the water, as you can see in the pictures. Okay, so the legs of the robot will be continue its walking motion performed on land, while the feet will be start pedaling ups and downs. So it will be imitate the motion of a duck, okay, by the help of the servo motors. So the pedaling motion of the robot will start once it enter the water, which will be detected by the water sensor placed under the robot. Okay. So basically our robot have 4-leg design. So the robot because it we aims to increase the stability of the robots. Okay, for the explorative mission and also delivery service in the unmanned areas. Okay, so it also can make the robot to handle heavy delivery and also transportation of goods in time of crisis. Okay, and the 4-leg design also we will be greatly help in the walking mode and also especially in the walking mode, as it will produce a greater force. Okay, so basically this is our design for the robot. So you can see the body is like a boat body, so that it can be floating on the water, in the water. And also we also have the waterproof design for the robot and also airtight body, and with the help of the styrofoam, okay, for so that the body will be float on in the water. Okay, so on the left you can see the feet, the webbed feet design of a duck. So at the center of the feet you can see the hinge like a door. So when the feet move forward, the hinge will be open, so that it will reduce the friction of the water. So when it move backwards, the hinge will be closed, so that it can produce a greater force in the water to for the robot to move forward. Okay, so the material basically used in our robot to build the robot is we will be using the aluminum. Okay, because of the aluminum has the high heat tolerance, and also it is affordable. And while our robot will be using the boat-like shape, which the aluminum can be is malleable, can be can produce the body of the robot easily. Okay, so the robot will be have the floating body designs, also waterproof legs, which and also by using the aluminum, the material itself actually is the higher in density compared to the water, but that's why we have the airtight body and also aid with the styrofoam to use to keep it floating in the water. Okay, next.
Moving on, we have the actuators of the robot. First, we have the waterproof EMAX ES3005 servo. So since the robot legs will be placed underwater, so a waterproof servo is used, which is why we chose this model. So this is to ensure that the robot operates safely, which also while in the water. So the servo chosen has the right size for the robot's feet, as well as its the torque and the power consumption that it provides, which is also suitable for the robot, which is why we chose this robot. High torque of the robot allows the robot to pedal underwater effectively to overcome the friction of the force of water. Okay, next slide. So here we have the specification of the robot, as you can see. Okay, next, DC gear motor model JG-V37. So since the robot will be using, we have 4 legs, 4 DC motors is used. So this DC motor will be placed at each of the legs of the motor, and since it will be only used to operate the robot's legs, the 30 RPM speed, rotational speed, is suitable for the robot. Additionally, the torque is also at 2.45 Newton meter, which is enough for the robot to move on land and in water. This specification has shown to be suitable for the robot as it needs to carry the whole robot in order to move. Here we have the specification of the DC motor chosen. As you can see, at 30 rpm at no load, which is suitable for the robot's legs. Moving on, we have the motor driver. Since a DC motor will be used for this robot, a motor driver is required to operate it. So DC motor demands high current, which is why a motor driver is used. And for the DC motor, the specification of the motor driver that we are using has two channels, meaning that it can operate two DC motors at the same time to ensure synchronization of the motor. This also helps the robot to move its legs smoothly while operating. So here we have the specification of the DC motor. So the reason why we chose these motor drivers is also because of based on the current and the voltage that the DC motor provides or requires. That's why we chose this model. The next is the navigation system and controller. So first we have the Arduino Mega microcontroller. So the main reason we chose this model is because the number of pins that are available in this model. So this can help cater with the needs of the design and modules that are used in the robot, which can be seen earlier and move up next in the presentation. It also features a faster transfer rate as compared to its predecessor, meaning that the transfer rate between the Arduino and the module can be conducted faster and more efficient. So here are the specifications of the Arduino. So we can see that the price is also suitable for this. It's also quite cheap compared to other microcontrollers, meaning that it can save costs for the overall price of the robot. Next we have the GPS module. So this module will be used to identify the robot's positioning, which is a crucial component for explorative missions as well as rescue missions. These two missions rely heavily on GPS module, which helps the user to identify the robot's positioning as well as the positioning of the victim in search and rescue mission. Okay. And next we have the specification of the GPS module, which can be seen. Okay, moving on, we have the water sensor. A water sensor is used to identify the robot, the maneuvering mode of the robot. So the water sensor will be placed at the bottom of the robot, whereby whenever water are detected, the robot will instantaneously switch its mode from walking to swimming, which activates the robot's pedaling mechanism. This helps the robot to maneuver itself efficiently in both land and water. So in swimming mode, the robot's walking mechanism are enabled like in the walking mode, with the feet of the robot paddling in water like a duck. Here we have the specification of the water sensor, as you can see. Okay, last but not least, we have LiDAR sensor. So for this for the sensor LiDAR, we will be using the TF Mini S micro LiDAR module from the time of flight LiDAR sensor. So the sensor is capable of measuring distance at object as close as 10 centimeters and up to and as far as to 12 centimeters. This LiDAR is also Arduino friendly, meaning that it can be programmable by only microcontroller that we are using, which is Arduino Mega. This means that the LiDAR is suitable for our robots design. It is also a single point ranging LiDAR based on TF Mini upgrade. The blind zone is shortened to 10 cm. Outdoor performance and accuracy of different reflectivity are also improved. It can achieve a stable, accurate, sensitive and high accuracy risk detection, meaning that this LiDAR is also highly accurate, which is suitable for our robot, especially for search and rescue. So next, here you have the specifications of the robot, of the LiDAR sensor.
Assalamu alaikum. So now that we know that our robot can move around and navigate by itself, we have to utilize this design to collect data. So firstly, we will use the camera. Next, please. So we will be using the ArduCam to collect footage to the area surrounding the robot. This will maximize the efficiency for search and rescue missions. This cam will be able to take photos and videos. However, the video will have a few frames per second, but it should be enough for the exploration task that we want the robot to do. Next. These are the specifications for the camera, lightweighted. Next. Next. For data communication, we will be using the Wi-Fi model that we've been searching about this Wi-Fi model specifically because it works well with the camera. So this Wi-Fi model will be able to search for this will have sorry. This Wi-Fi model will be compatible to our camera and the Arduino Mega for easy customization. So, however, it have a limitation for range between 45 meters to 90 meters, but it should suit our tasks. Next. And this is the specification for it. Next. So now that we have the camera and the Wi-Fi, we need to utilize these items by using a remote controller that can control the robot in dangerous zone that self-navigating mechanism might not work. So we need to move it manually. This controller is good because we can switch between modes, between the walking and the swimming mode, and also with the ability to kill switch the robot itself to stop to stop being danger from itself or its surrounding. Next. This is some simplification. Next. And for power management, we will be using the lithium batteries. We will be using 6 lithium batteries. They will be in two in parallel and 3 connected in series. When they are connected in parallel, they will increase its capacity. However, when it will be in serial, it will increase the voltage that we need. So the battery of 3.7 voltage connected in series will give us the power of 11.1 voltage. This battery also is rechargeable, which can be useful when in the middle of the mission the battery is out. We can just replace it and recharge it at the same time. Next. This is some of the specification. As you can see, it can it have life cycle of 500 time rechargeable if we keep it in good condition. Next. Next. So for battery life, we are calculating the total current consumption, and we get it as 9.04. And we have done some calculation with safety measurement by increasing the consumption by 20%, and that will lead us of usage to 1.8 hour, almost 2 hours. Next. And for safety concern, we made sure that the robot material itself, next, we made sure that the robot material itself are waterproof, and the material that need to be then the material that need to touch the water are what it can be used in water, and which will allow it to operate without any issue. And also we included a dead man switch on the robot, so it can be turned off at any time if it behaves in weird way, to stop damaging itself or damaging its surrounding. We need to make sure that the robot is within 90 meter from the user, because within this range we have the ability to see the video cam, and also the GPS will help us to find it in case it gets lost. Next. So to conclude, next please. The Moby Duck robot is best used as a service robot in areas between water and land for rescue and exploration missions, with the ability to navigate by itself with a user controller while sending live footage to user without putting them in danger. And thank you very much for any questions? Hello?
I have a question.
Go ahead.
How do you think this robot give advantages to the society?
So when we were thinking about the design, we have most service robot need to serve a certain. They have certain criteria. We have thing called the 3Ds that we need to do, so a service robot can do its task very good. So the 3Ds are dangerous. The task need to be dangerous or and dirty and demanding. So with these three criteria, we were thinking about sending a man to a small cave or a hole. It could be dangerous or even demanding mentally. Can you imagine yourself in a cave with a dark and cold water? So it's hard work. Also could be used in dirty areas or toxic polluted water. So in the end, this server can be sent to this area to rescue people or to even send things in this dangerous environment. I hope this question, I hope this answer satisfy you.
Thank you, brother.
Okay, next question. Anyone?
Hello,
Yeah.
I have a question. So, what can you do or add to improve the current version of your robot in the future?
Oh, okay. So basically, right now our robot has the limitation between is the range limitation, which is 90 meter only, because it using the Wi-Fi. So in future, maybe the robot can use the GSM module, which can supply its own internet to the robot, so that it can give the live feed video without any limitation. Okay, so that's one of the things that the robot can be improved. And also the materials can be improved also to can withstand more heat tolerance, and also the lightweight material. I hope that's answer your question.
All right, thank you.
Any more question?
How do you make sure the robot is waterproof?
allow me to answer the question. As mentioned, to make sure that the robot is waterproof, we will be using for the legs we will be using waterproof servos, waterproof components, which is the aluminium sheets, and waterproof design, which is the duck feet. So in order to, this helps to make sure that the robot operates safely in the water, especially for the waterproof servos and the legs. So as for the body, since we will be having a boat-like design, meaning that only part of the robot will be submerged, part of the body will be submerged in water, the robot will be made to be airtight, meaning that no water can enter the body, which makes it waterproof. Additionally, the bottom of the robot, which will be underwater, is made of is included with styrofoams, meaning that there won't be any components inside this part of the robot. So for the components that are not waterproof, which is inside the robot, which we will be placing it above the styrofoam, meaning that it would be fully submerged in water. This helps the components to remain safe while the robot operates in water. So hopefully that helps answer your question. So is there any other question from the audience? So I think that's all for our presentation today. Thank you for your time and hope to see you soon. That's all. Thank you.